Angles of elevation and depression, problems with two triangles. From a lighthouse 43 meters above sea level, the lighthouse keeper observes a lost swimmer at an angle of depression of 57 degrees and a rescue boat at an angle of depression of 21 degrees. How far is the rescue boat from the swimmer? This is a really typical type of question, and it's important that we look at how to deal with it. So start with your diagram. Here is your lighthouse, 43 meters above sea level, and here is sea level. Keep it nice and simple. The keeper observes a lost swimmer at an angle of depression of 57 degrees. So remember that our angle of depression is from the vertical, and if you're up here where the lighthouse keeper is, it's a good idea to draw yourself a dotted line on his vertical or her vertical, oh my God, horizontal. I'm sorry. Angle of depression is from the horizontal, and it's a good idea to draw your horizontal line of sight and then looking down at the swimmer. Now, a question that you might want to work out is, well, is the swimmer closer or is the rescue boat closer? And that has to do with the angle of depression. If you look at an angle of depression of 57 degrees, quite a large angle here, that'll put the swimmer down about here. An angle of depression of 21 degrees, not as much, might put that rescue boat out here. So you can work out from the size of the angle which is closer and which is further away. So let's put our swimmer down here and our rescue boat down there. Now, these sort of questions do assume that the swimmer and the rescue boat are observed out in a direct line. You look at that one, then you look at that one. And you sort of have to assume that. You assume, okay, well, sea level is level, a cliff is vertical, etc. Okay, so we put in our angles. Now, you can put your angles of depression up here, but it's often easier, since angle of depression and elevation are the same, to put them down here, because then it's less crowded up the top. 57. And now what we have is two triangles. Now we've got three. We've got this triangle in here as well, but that is not a right-angled triangle, so we can't use it. What we want to know is how far the rescue boat is from the swimmer. I want that distance there. But to get that, I'm going to have to find this distance with my little triangle, that distance with the big triangle, and subtract. You can't just get this value because it's not part of a right-angled triangle. And these questions happen all the time, that there's two triangles, two angles are involved, and you're going to have to use both triangles, the big and the little one, to get your answer. If you get at all stuck at any stage, redraw just the triangle that you're working with. So x is what I want. I'll call this little value here y, because I need this bit. And I'll find that whole distance across there. I don't know, I'll call that q. Now that's getting pretty confusing. So let's find y. And so that I don't get confused, I'll draw just the triangle that's got y as one of its sides. That's easy. Label our sides. We do get a lot of the tan ratio with angles of elevation and depression. Substitute, choose your ratio, substitute your values. Oops, this is y. Unknown is on the bottom, so we are dividing. And grab your calculator. 43 divided by tan 57. Sorry, my calculator's pretty dodgy. And I've got 27.925 meters. Now that's the distance of the swimmer from the base of the cliff. Keep more decimal places than you need until you get to your final answer. So now I have to find Q, this distance from the cliff to the rescue boat. Again, it is a really good idea to draw the triangle that you're currently dealing with so you don't get confused. Label your sides. And work out okay, so Q here is 112.019 meters, and now you can find X. You'll notice I'm actually labeling in each part of my working what it is I'm finding, so it's quite clear. X is not part of a right-angled triangle, so we don't draw that, but you can say what your working is, because X is going to be Q minus Y. And so X is 112.019 minus 27.925. Grab your calculator. X equals 84.1 meters. So you see, when I was going to one decimal place in my answer, I kept 3 decimal places in my working. And because it was a word question, here is the actual question: how far is the rescue boat from the swimmer? You give a word answer. The rescue boat is 84.1 meters from the swimmer. So your strategies are: carefully draw your diagram, draw the individual triangles that will let you work that out, and only go for right-angled triangles if you're using right-angled trigonometry, which is all we've learnt so far.